All right, so let's look at pins. And uh, if you look at your microcontroller that sits here, around it is a lot of pins that goes to different places on your board. So some of those pins will go to the buzzers, some pins to the LDR, and so forth. So both AI and conventional coding will require that you tell it what is connected to your microcontroller and on what pin of the microcontroller it is connected to. In AI, it's easy, and there's a file in this lesson that you can download that you just upload into your AI prompt, and now the AI will automatically know what's on your board and what is connected to what. And from now on, you can just with AI say, check the value of the LDR or make the buzzer buzz without having to worry about having to tell it what pins to use. Conventional coding, however, we still will need to code that in specifically. So we have 6 LEDs on that board, IO pin 10 to 14, and then pin 21 as well. So let's use pin 14 just as an example. That will be the 4th LED on your board, and we'll make that flash on and off. Let me go to our cursor and look at how this whole thing fits together. If you go to File, Examples, Basics, Blink, you'll very much get this sketch showing up, except it will also show all this comments. So I'm taking the comments out for now, so we sit with just the code. What you'll notice is there's something called LED built-in, and I want to talk about that first, because what Arduino did was that it's got many boards like the Arduino Uno, the Mega, the Nano, and so forth. And the onboard LED, the board that's on the board, or the LED that's on the board, will be connected to a specific pin. And on different Arduino boards, it's on different pins. So what Arduino did was to say, all right, so if you choose the Uno, LED built-in will automatically be assigned to that onboard pin on the Uno, and it will do the same for Mega and so forth. So we're not going to use it. We're just going to type in the pin number. All right, so the first thing here in setup, what we do is we're going to tell the software, are we going to use input or output? Remember, input means volts coming into your microcontroller, like for instance, the value of your day-night sensor. It comes in. Output means we're going to put volts, 3.3 volt, on a pin like for an LED, so that the LED can switch on, or for a buzzer to buzz. So we need to specify that, and we use the pin mode function to do that. We learn about functions very soon. And we put it in setup. The reason why it's in setup is we just have to assign it once. If you're going to put it in loop, it will continuously assign pin 13 as an output unnecessary. So it's only when your computers or your microcontroller starts up, or when you reboot it, it will read it once, and it now knows that pin 13 is an output, so it will put volts on the pin or not put volts on the pin. Next is digital write, and all digital write will do is to say this pin will have its 3.3 volt or it will have no volt. true means or high means, you can use true. High will means there's 3.3 volt now on the pin. Low means there's not 3.3 volt on the pin. And of course, we also have to change this to the actual pin number. And we'll have to do the same here. All right, so pin 13 will get volts, and then the volts will be taken away. But we put a little delay in there, 1000 milliseconds, which is 1 second. So it will go high. LED switches on for 1 second. It will go low. The LED switches off for 1 second, and it will start all over again, looping until you switch off your microcontroller. We can, for instance, and you can do it just for fun, maybe let's make it half a second, 500 milliseconds. So it will go on for 1 second, go off for half a second, then go on again for a second, and so forth. Also, just for fun, you can play around, change 13 to 10 or to 21 if I remember correctly, and see how the different LEDs goes on and off. So let's just upload the code and see if it's going to work. There's the compiling going, and there's the uploading going. And if you do that, you'll see that your, well, we did this, I said pin 14, but then I went for 13, but that's fine. So you'll see one of the LEDs blink on and off. You can change this to 14 as an example, upload it again, and you'll see pin 14, the LED connected to pin 14 will now go on and off. You can also, just to play around a little bit, get familiar with a bit of this coding, you know, let's also assign pin 21 to it. Right, and then let's also get pin 21 to go high. So 2 pins will now have volts on it. It's 2 different LEDs. So let me just make this 21. And this 21. And now what will happen is 2 LEDs will go on and 2 LEDs will go off. You also can try to say make LED 1 go on, wait a second, get the second LED to go on, wait a second, get the first one to go off, wait a second, get the second one to go off. Play around with it. You can't break anything by programming here. You can't destroy your board. The worst that can happen is that you will have an error in your code, and it will even tell you what the error is. I might, by mistake, have a C in there, and I can say upload, and what you'll see is it will come back with a error, and it will even tell you on what line the error is. And oh, right, so I put a C in there, that's wrong. No harm done to the board, but you fix it, and then you run your code again, and all is good to go. So that's it for this lesson. In the next lesson, we're going to start talking more about conventional programming and so forth. I'll see you in that lesson. Have a great time.